Okay, so we're going over our warm-ups. Number 1 is yes, because if we have one pair of sides that is both congruent and parallel, that is enough to prove a parallelogram. Number 2 is yes, because the diagonals are bisected. Do you see they bisect each other?
Yes.
Number 3 is yes, because the opposite sides are congruent. Both pair of opposite sides are congruent. Number 4 is no. And the reason it is no is if I can draw a different figure with the same information, that tells us it doesn't have to be a parallelogram. It looks like a parallelogram, but what would happen if I swung this 12 this way?
But it says that the two top ones are both equal.
No, they're
No,
parallel.
it says they're parallel.
I thought those were dots.
Oh, those are arrows. If you thought they were tick marks, then I can understand. If you thought they were tick marks, then that makes sense.
I thought they were those.
It's actually parallel arrows. Okay, so this one's a no because it could be drawn that way. So, you may not go by appearances, you have to go by marks. And I can totally see why you thought that was the other. If I had printed this out, you could see it. All right, number 5.
Yes.
You've already seen it's yes. Why?
Because it says
Because. Yes, that is why. Okay, right now, this is congruent to itself. So I have triangle congruence by angle side angle. Does everybody follow that? This triangle is congruent to this triangle by angle side angle. So, corresponding parts of congruent triangles are congruent. So, because of that, these two are congruent and those two are congruent, so opposite sides are congruent. It's enough to prove parallelogram. Okay, and on this one, because they gave us both consecutive angles, we can say yes, because that's 180, that's 180, yes. An angle is supplementary to both the consecutive angles. All right. This one, number 12, we could have gone 2 ways with it. We could have gone with the definition. And the definition of a parallelogram says opposite sides are parallel. So this parallel to this. And what else could we use? That AD is parallel to BC. Or we could go with the fact that they could be parallel and congruent. So you had to have this one or that one. Make sense? Okay? Same thing here. We could say that these two sides are also parallel. Or I could say that the other pair of sides are also congruent. On this one, angle DCA is congruent to BAC. Okay, and then what I would need is that this angle is also congruent to this one, because then we're back to this problem in number 5, aren't we? Then it looks just like that, and we can have triangle congruence. So you need angle DAC is congruent to angle BCA. Okay, number 9, DE, congruent to EB. So I would need that this diagonal is congruent to that one, AB to EC.
Wait, so if one...
That's number 10. Oh, I just went over number 9. So that's number 10.
So if one diagonal is bisected...
That's not enough.
So that doesn't mean the other one's bisected?
Nope. That's not enough.
Then how did you get that from number 9 again?
So number 10 told us that this one's bisected.
Mm-hmm.
So what would I need to add to that? That's what this is asking us.
Okay.
So we need to add that that is congruent to that.
Because if both of them bisect each other, it has to be a parallelogram.
All right, this one says that angle CDA, that one, plus DAB, this one, add up to 180. Okay, so what else would we need?
Angle D is equal to angle B.
We would either need that this one plus this one, those two, equal 180. So I've got both consecutive angles supplementary. Or I would need this one and this one add up to 180. So I could go either way with number 11. Got it? Okay. And then there's 12, 13, 14. See if you have any questions. Oh. Sorry. Went away. Really hoping I could go outside and just stand in it. Alright, any questions about 12, 13, and 14? As we commiserate about not being able to stand in the sunshine.
Is it raining?
No, it's not raining, it's just not sunny.
Still good.
Alright, take a look at 1 through 14. I've got 15 rewritten over here where it's neater. So take a look at 1 through 14 and then we'll talk about the proof for number 15 in a second. Oh, and while you start doing that, we're going to do honesty policy on the homework. That means if you did it all, you say yes, ma'am. If you did more than half, say more than half. If you did less than half, say didn't do it. All right, Lou.
Yes, ma'am.
Colton?
Yes.
Trey?
Yes, ma'am.
Olivia? No, no.
Mine's at home.
Is it?
I did it, but
Show it to me tomorrow, please. Leo?
Yes.
Jessica?
yes.
Are you working on your makeup work too? Awesome. Will? Yes.
More than half.
Okay. Sarah Grace?
Yes, ma'am.
Bailey?
I did half.
Okay. Ian?
Yes, ma'am.
Hayden? Tyler?
Yes.
TJ?
More than half.
Sabrina?
Yes, I did do number 9, but it says omit number 9.
It does. It's okay. Colin?
Yes.
Chow? Annabelle?
More than half.
All right. Emily?
Yes.
All right. And Rose.
Yes.
Awesome.
There was a fully cold. What?
Okay. Number 9. I really should omit from my calendar. I need to go do that. The reason being is you don't know how to factor yet. And you have to factor that problem to solve it. So number 9 is worked out. So hopefully you can set it
Oh,
up.
I got it right.
I got it right.
You got it right.
Oh, well, no, a senior told me how to do it, though.
Okay.
I figured it out by myself.
I like it.
Yay.
The answer, well, you should have found out that Z was 6
Yeah.
and then plugged it back in to get 117. I mean 71, not 117. I was right here.
We're so good.
But this is something that you guys don't know how to do just yet. But stay with Accelerate, and I can teach you how to do that the first semester next year. That's right.
Are we gonna have you again?
Well, it could be me. Sometimes I teach students 2 years in a row. Sometimes I don't. Currently, this year, the last several years, I teach the Accelerated 9 and the Accelerated 10. So sometimes I have students back to back. So everybody don't go run to your counselor and beg to not have it next year.
We'd rather have you.
Anyone but Miss
Can
Woody.
you go back up for a minute?
Miss Morgan also teaches it. She's an excellent teacher.
Wow, I'm surprised. I don't get it right. You got the y axis, right?
Down here in 15?
I had 4 steps.
I had very few. I didn't have this many. I like mine better.
I got stuck at because I put C, B, C, T, C.
Me too. I put their last one.
It's independent. I did alternate angle. I did alternate angle
Yeah,
twice and then transitive.
I got that. I got some alternate.
Because I was looking at the sheet that you gave us yesterday, like weights and stuff
Yeah.
like that.
Okay. Guys, so the book they have all these steps for their proof, and they did some substitution, they used the transitive property, they did the subtraction property of equality. Mine's a little different. And this just goes to prove that there's multiple ways to do a proof. Alright, so this is what I said. DEFG is a parallelogram given. Therefore, DE is parallel to GF. That's the definition of parallelogram, right? Opposite sides are parallel. So, these two are congruent because the alternate interior angles are congruent. If angles are congruent, then their measures have to be the same. That's the definition of congruent angles. Okay, and then this plus this has to equal that because the sum of the two remote interior angles is equal to the exterior. Then we can just use substitution. Substituting, and we're done. Because GFH is equal to EDH. Substitute. You did yours differently?
Yeah, but I don't know if I did it correct.
No, either.
It's harder when they don't give you any direction on all, isn't it?
I wish
Yeah,
we
it's
had
a
like, at
lot
least
harder.
one line.
One line. Did you get this one and this one at least?
Yes.
And then I heard some of you had some alternate interior,
Yes.
and you had transitive.
Yeah, but
Okay.
I did mine wrong.
I had substitute.
I thought
I
thought
had
it
some
was-
substitution too.
Oh, equal, not plus plus.
I don't know what I did.
Can you come look at mine and tell me where it's like equal?
Okay, you can't do CPCTC until you've said a triangle is congruent to another triangle. Okay. 138, guys. 138.
It literally took me like an hour last night to figure out that you, instead of setting the equations equal to each other, you add them instead of equal. That was like second recipe.
Oh no.
Yes.
Oh, I mentioned this the last period. I'm going to show you guys too. You probably already know this. But in case anybody asks about this section, this is, you guys can only see these two tabs. Where's my, there we go. Where's the, is it, yes, I'll show you. Never mind. I know. All right. So you guys get these first two tabs. If you click on Student Resources, and if you look at the top of the calendar for each day, it tells you what section we're in the book. Did you guys know I put that on your calendar?
I do now.
Yeah. If you look at your calendar, let's go to Willoughby World. Willoughby World. Willoughby World.
I really like that experience. Be rational and get rid of it.
Okay, so you see right here, that was yesterday. I told you we're in 7-1 and 7-2.
So you can like copy and paste them.
So, yeah, So look right here. If you click on lesson resources, did you guys know that this is your workbook? So if you ever forget your workbook, it's right here.
Oh, that is awesome. I like this.
Okay. It didn't go to 7-1. Alright, so here's my workbook. Click on it. And you guys were saying you had some questions about 138. So we'll look down here at 138. Which one?
I got
Number 1.
do number 2.
Number 3. Number 1.
2.
Number 4.
Yeah, number
1,
4.
2, 3, and 4.
I need
I got
5,
number
6,
1,
7 was supposed to be.
3, and 4.
Seriously?
No, I was
Okay, you're just messing with me.
just so that you had to do all.
Just wanted to, okay, I have a little bit worked out here. Let's see if this is enough, guys. On number 4, they gave us TUV, which is this angle right here, and they said it's 8x plus 1. And then they gave us UVW, which is this one. Okay, so if this is a parallelogram, these are consecutive angles, and consecutive angles are supplementary. So you had to add them up and set them equal to 180. Same thing here. If this is x and this is 3x, then we have to add them up and set them equal to 180. Does that make sense? Okay, so these are all the same. So if this is 45 and 135, then this would be the same. Okay, somebody said 2. Alright, so on 2, FH is 5x, and EG is 2x plus 4. GJ is 8 inches. Okay, so we know that this gets bisected. So if GJ is 8, then the whole thing has to be 16. So we set this equal to 16 and solve for x. Once we've solved for x, we can just plug x back in here. Okie dokie. Did that help at all?
Yes.
Okay. All right. Does anybody have any questions about this one? 6. X plus 5, x plus 5. Add them up. Set it equal to 54. Okay. Cool. And then page 1. Okay. Apparently I wrote on the board yesterday page 140 instead of 141. So if you copied it off the board, you didn't do these problems. But if you check the calendar, then you did. So, yeah. So I had a little oops.
I did check the calendar, but I did not. Page 141. Sorry. Ooh.
Alright. Okay, so yesterday I handed you the what do I need to prove sheet. It was our second copy of what do I need to prove. And yesterday we talked about parallelograms. So there were six choices for parallelograms, right? Opposite sides parallel, opposite sides, 2 pair of opposite sides congruent, 2 pair of opposite angles congruent, 1 pair of opposite sides congruent and parallel. Diagonals bisect each other. And then the 6th one was 1 angle is supplementary to both consecutive angles. Okay, so those were our 6 choices for a parallelogram. All right, today we're going to go back and revisit rectangle, rhombus, and square. Okay, so since we're going back to revisit these, somewhere in here, I have them all. There they are. Okay, let's see if we remember everything about the parallelogram. Let's erase it all and start from nothing. Okay, so parallelogram. Definition of parallelogram: opposite sides are parallel. And opposite sides are congruent. Opposite angles are congruent.
Diagonals bisect each other.
Diagonals bisect each other.
Oh, that was like perfect.
It just got real.
1, 2, 3. 1, 2, 3. 1, 2, 3, 4. All right, and then consecutive angles are supplementary, but there's not a great way to write that. I could say 1 arc plus 2 arcs equals 180. There we go. All right, so that's a parallelogram. Now, if you remember about the rectangle, diagonals are congruent. So when it bisects each other into 4 congruent parts. Okay, a rectangle also has to have a right angle. If it has 1, then it will have 4 because a rectangle is a parallelogram. Remember, everything that's true about the parallelogram is also true about the rectangle. Everything that's true about the parallelogram is also true about the, what's this figure? Rhombus. And by definition, a rhombus has 4 congruent sides. By definition, a rectangle has 4 right angles, right? Okay, and then another cool thing on this one, our diagonals, they bisect each other because it's in the parallelogram family, but they are also perpendicular. And those diagonals are going to bisect opposite angles. Okay, and so everything that's true about the rectangle and everything that's true about the rhombus is true about the square. So, all this is true, diagonal stuff is true, we've got right angles, whoops, those need 2 tick marks. Okay, so everything that's true. So when we come back and we look at the sheet from yesterday, here it is. How do we prove that a quadrilateral is a rectangle? Well, if we prove it's a parallelogram, then we only need to add one thing. So, if a parallelogram has at least 1 right angle, then it's a rectangle. So if we can pick one of those 6 things from parallelogram that we've already went over, and show it has a right angle, then we've proven it is a rectangle. Or, if we pick one of those 6 things from the parallelogram, and we show that the diagonals are congruent, then it's a rectangle. Now, if we didn't prove parallelogram, but we see 4 right angles, then automatically it's a rectangle. We don't even have to prove parallelogram. That is the definition of rectangle, a quadrilateral with 4 right angles. All right, how do we prove rhombus? The rhombus is in the parallelogram family. So if we have proven parallelogram using one of those 6 choices, and we show that a pair of consecutive sides is congruent, then it's a rhombus. By definition, all sides are parallel. All sides are congruent. If a diagonal of a parallelogram bisects 2 angles of the parallelogram, then it's a rhombus. And we drew that on the picture. If the diagonal is bisecting two angles of the parallelogram. And then finally, if the diagonals of a quadrilateral are perpendicular bisectors of each other. Without proving parallelogram, we prove in rhombus. Because if the diagonals have bisected each other, isn't that enough to prove parallelogram? So that really isn't like a quick way. So perpendicular bisectors. And square. To prove a square, we have to do one thing that proves it's a rectangle and one thing that proves it's a rhombus, and then we have proven it's a square. Okay, so this is in your book on page 224. If you have your book, you can follow along. If you don't, you can follow along looking at the screen. And it talks us through these additional special quads. So yesterday we talked about parallelogram. Today we're going to talk about rectangle, rhombus, and a square. 224. All right, so by definition, a rectangle is a quadrilateral with 4 right angles. And we just spoke of this. If a quadrilateral is a rectangle, then it is a parallelogram. Does that make sense? If it's a rectangle, then it must be a parallelogram. Because by definition, rectangle has 4 right angles. So does this show that A is supplementary to both B and D? Yeah, that proved it's a parallelogram, didn't it? So we can say a rectangle is a parallelogram. All right, this one, if a parallelogram is a rectangle, then its diagonals are congruent. So whenever we have a rectangle, we can say that the diagonals are congruent. And it also bisects into the 4 little congruent segments there at the intersection. All right, so on a little lower down on page 224, we have this picture of this pretty stained glass. An artist connects the stained glass pieces with lead strips. In this rectangular window, the strips are cut so that FG is 24 inches and FH is 34 inches. Find JG. Okay, so if FH is 34 and we are told this is a rectangle,
18.
this would be 34 divided by 2, 17, and 17. But on a rectangle, didn't we say all the parts were the same? So if these 2 are 17, these 2 would also be 17. Okay, so here's the this logical steps of thinking through this problem. EG is congruent to FH, so they're both 34. So if we take half of 34, we get 17. Got it?
Why do we need the FG? Is that just information that they just throw in?
Yeah, they're just messing with you. Yes. Extraneous information. Not needed.
I don't like it when you do that.
Okay. Then your book goes back over the properties of the rhombus. By definition, it's a quadrilateral with 4 congruent sides. So this proves it's a rhombus, doesn't it? Because we have 2 pair of opposite sides that are congruent. So a rhombus is a parallelogram. It falls in the parallelogram family. If a parallelogram is a rhombus, then the diagonals are perpendicular, and we talked about that just a moment ago. If a parallelogram is a rhombus, then the diagonals bisect a pair of opposite angles. So in this problem, if I told you that angle bad was 50, we also know that angle BCD would have to be 50. And because these are bisected, that means that this is congruent to that, which is congruent to that, which is congruent to that. So we could just take this and divide it by 2, couldn't we? And get 25 degrees. Okay? All of these would also be congruent. 1, 2, 5, and 6. 1 and 2, 5 and 6, 3 and 4, 7 and 8. Those are the congruents. Okay, so big things about the rhombus. As 4 congruent sides, the diagonals are perpendicular, and opposite angles are congruent, and they are bisected by the diagonals. All right, so here's a picture of a rhombus. And how would we find BT?
Oh,
All right, so BT is this side, but we know that all sides are congruent. So all we would do is set this equal to that and solve. And it shows you that in your textbook. Set them equal, solve for x, and then plug back in, and you get the length of BT. Make sense? Okay. A square. We talked about the square has all the qualities of the rectangle and the rhombus, and both of these contain everything from the parallelogram. So all that is true about the square. So the square has properties of all 3 other special quadrilaterals. All right. So how would we complete proofs? And we're going to keep doing proofs. Every day, a few more proofs. And then I've already sent your review packet to be copied. There's a page and a half of proofs in it. And then we have some proofs that we're going to practice in class. And we have some puzzle proofs we're going to play before your test. So lots of proof practice. Huh?
But I could do formal like this.
Yeah, I sent it to be copied today. Alright, so we're on page 227 in your textbook, looking through this proof. Alright, it tells us EFGH is a rectangle and J is the midpoint of EH. So before we ever start the proof, let's talk through this, guys. If it's a rectangle, are those 2 right angles? Yes. J is the midpoint of EH. Doesn't that tell us that this is congruent to that? Well, if it's a rectangle, isn't it also a parallelogram? And so opposite sides would have to be congruent. Do I have 2 congruent triangles here? Yes.
By SAS.
By SAS. And aren't corresponding parts of congruent triangles congruent? Yes, CPCTC. So now don't I see that I have an isosceles triangle by definition?
yeah.
All right, so that's all this proof does, is it takes us through those steps. So the first one was given. E and H are right angles because that's the definition of a rectangle, right angles. And right angles are congruent, aren't they? Okay, right angles are congruent. You could write that. EFGH is a parallelogram because all rectangles are parallelograms. And look how they write it, guys. Take the shortcut. Write it like this. All rectangles are parallelograms. Okay? So, if we have a parallelogram, then opposite sides are congruent. And by definition of midpoint, we know that this is congruent to that. So therefore, we have congruent triangles by side angle sides. So that third side must be congruent by corresponding parts of congruent triangles are congruent. So we've proven it's isosceles by definition of isosceles.
What is the definition of isosceles? Is 2 congruent parts of 1?
All rectangles are parallelograms, but not all parallelograms are rectangles. Yep. All right, so your homework's out of your textbook. It's 10 through 15, and 19, and 23 through 31, and finally 35. Okay, you have 4 minutes if you want to get started.